Well, welcome back, everyone. Now I'd like to introduce David López Meco. He's head of SOC transformation at Telefónica Tech, and he's going to be sharing a presentation on digital resilience, technologies for a safer future. Over to you.
Thank you. You hear me? Yep. Everything good. So thank you, everyone, for coming. Thank you for the presentation. Let's go. So what you have here are two photos of two different manufacturing companies. One is a car manufacturer. The other one is a solar panel manufacturer. And both have things in common, or several things in common. The first one is that they are highly automatized, robotized. But this is just the tip of the iceberg, OK? For every piece of hardware that you have there, you have a control system or a digital footprint, let's say. So everything that you are seeing here in the photo has or is a physical or cyber-physical system, OK? And on the underlying, those companies made a great transformation effort. They transformed the IT infra, the OT infra. They migrated stuff to the cloud. They basically did everything in their hands so that they can achieve these photos. The thing is that everything comes with a cost. We are talking here about cybersecurity. And in cybersecurity, if you connect something, even if you think that it's not connected to a cloud, or even if you think that you are using a private connection, once you connect it, you are at risk. And that's period. It's everything and every time true. So what we can see here is a figure, is a report of the share of incidents among the different industries. As you can see, manufacturing companies right now in 23 and probably in 24 are in the top one. 1 every 4 incidents or attacks is against these kind of companies. And why? As I said, they are connected, but they have also one thing in common. All the assets that they manage, all the processes that they manage are critical, are mission-critical processes. So they are a honeypot for all these cyber criminals because they know that either they can make a huge impact on lives of people, for example, in a nation-state attack, or either they can just get money because it's so critical that the people managing those companies prefer to pay, as we will see in some of the slides later. The thing is that the result in the 23 is shocking, but it's more shocking the way that they came from 80% of the incident share in just in the 19, to 25% in the 23. All this digital transformation that I was showing in the previous slide is the underlying reason why this changed from 8 to 25. It's massive, OK? So this is just in the reports? No. You can check it for yourself. You are the owner of one of these plants, and you use any deception tool. A deception tool is a cybersecurity tool that emulates, that simulates an industrial environment. You can put there specific vulnerabilities. Usually companies use those deception tools to detect early the attacks, to learn from the cyber attackers, and then to put countermeasures in place. This is a honeypot developed by Telefónica for industrial environments and companies. This is a screenshot that I just took 2 days ago. And you can see there in the left side that in the last 7 days, they detected more than 12 million cybersecurity alerts or events. Not all of them will end in cybersecurity incidents, but you can see the magnitude of what we are talking about here. Once you, as I said, once you connect something to the internet, the cloud, even if you think it's secure, if you expose it to internet or to wherever the connection, you are going to be attacked. That's for sure. Period. And why is this happening? This is a very simplified architecture of a network in a plant with the typical layers that we will see later in the Purdue model. And even if you think that this is a closed architecture, it is not. Okay? Usually, you give access to some people that connects in remote because they need to do maintenance work or whatever the reason. There's a lot of reasons. But if you don't securize this connection properly, you are not using zero trust connections, or you forget that you gave access to someone and you forget to remove it, then this is a backdoor for someone to enter in your network. And right now, a lot of the connectivity within the plants is wireless. So someone can connect a device to the wireless network. It doesn't matter if it's 5G, 4G, Wi-Fi. And then if he can simulate that it's let's say, an authorized device, then they can get it in the network. And if you haven't properly segmented the network, then you have a problem as well. Also, the workers get in and get out the fabric. If they take the PC with them and the PC gets infected at home and then bring it back to the plant, you have a problem as well. The mythical USB, misconfigured firewall, some protocols that were designed not for the Ethernet and they are not encrypted, those are backdoors. And to illustrate that, for example, you can, a very typical example, and there's thousands of malware attacks based on that. A PLC, I get more or less everyone knows what a PLC is. This is from Siemens. They have connection to a web server for controlling reasons, to send telemetry, etc., etc. This is one of the main backdoors for the cybercriminals to get into a network. Okay, there are very famous attacks based on that. So if you don't securize that and you don't segment the PLC, they can make lateral movements. So they get into the PLC, then go to the next step, until they reach a critical operating system, and they basically suck down the whole facility. And real examples. There are thousands of attacks. Very famous one, probably the most famous is the Colonial Pipeline in the United States there. Basically, they shut down the entire pipeline. Most of them are malware stuff. It's very typical in this industry because with the malware, they basically interrupt the entire operation. So it's very typical that they do it with malware. And the thing is that the impact is massive, either because they interrupt the service or because the cost is huge. If you stop a plant, not the Colonial, but a plant that produces food or whatever, every minute that the facility shut down is probably thousands or hundreds of thousands of dollars that you lose. So most of the attacks ends like that. They pay. And sometimes, and that's my personal opinion, they say they don't pay, but in reality they are paying, so the hackers get out of the network. So this is just the public information. So you need to be prepared. So that's the threat landscape, pretty bad. But I'm optimistic. And by the way, as I said, I'm David López. I didn't present myself, sorry. I'm the global head of cloud networking and SOC transformation. So all weird, strange projects in Telefónica around the SOC are on me. And also run the cloud networking business. So cloud Wi-Fi, LAN, secure SD-WAN, this stuff is also under my responsibility. So as I said, I'm optimistic. What I'm going to present is how Telefónica is approaching this kind of landscape, how we are helping manufacturing and other mission-critical companies in this space. But first, and as we are Telefónica and we are a telco, let me add the last piece of infrastructure into the equation, probably the newer one, is 5G. Okay, let's talk a bit about 5G, why 5G changes a bit the landscape, and then we'll get back to the cybersecurity stuff. So why 5G? I mean, wireless has been broadly adopted in fabrics, in plants. Wi-Fi, private LTE has been here for a while. And it's not, I mean, it's not massive, but there's a lot of manufacturing companies that are using 4G, private 4G to connect the devices into a fabric. And now we have 5G. The main difference is that 5G is like was designed for mission-critical use cases. It fits very well the mission-critical use cases because you can define network policies specifically for device. You can be very specific on the SLAs, QoS, network parameters, everything. So those elements that need a specific requirement that are deployed in the plants are well suited for 5G. There are other stuff, like the 5G network is better given the handover, especially in use cases inside a fabric where there are robots that are moving around. Escalates very well. In very specific scenarios, the cost is lower than the Wi-Fi. So there are plenty of reasons why you want to deploy a 5G network in a plant. It's still at the beginning of the adoption. Okay, that's the reality. But I'm sure that this will be that most of the connections inside plants, or at least most of the plants, will have at least one 5G private network deployment in the next years. Gartner, by the way, says that in the next 2 years, 75% of the worldwide 5G, private 5G network deployments will be done by manufacturing companies, precisely because of this mission-critical factor. So I have a private 5G network in my plant now. So what happened? There are plenty of things that happen. Some are not specifically inherent to 5G, but to anyone cellular network, but also to 5G, and they need to be addressed. We distinguish between at least two kinds of attacks. The ones that are targeting the network itself or are exploiting a network vulnerability itself. That would be the first one. You have there the names. I don't want to be very specific and very technical. And the second one, which is the one that I'm going to focus on today, is attacks that leverage the fact that mobile network is a flat network and is not segmented per se, so that they can move laterally using the 5G network. Okay. By the way, the 5G is a very secure standard. The security is stronger than the previous generations, but still it has some vulnerabilities that can be exploited. And once you connect something to the network, what you need to protect is the perimeter, not the network itself. Okay, that we assume that everyone is protecting the network. And by the way, we have a paper that we wrote with Fortinet about the resiliency inside fabrics, which I recommended to read. So let's deep dive a bit in the 5G or the security in the presence of 5G networks, which is not the same. I want to talk about security in 5G, but security in the presence of 5G private network, which is not the same. Here we have the Purdue model plus the specification, the EX6.644, blah, blah. And this is an industry standard. Is how you need to segment the network inside a plant, where you put the devices, these control systems that actually act over the devices, then the control system that act over the whole process, then the plant. So here you have the hierarchical level of the Purdue model. You achieve this by putting switches that are segmented at a VLAN level, putting firewalls between the different layers. So that's pretty good. And it worked very well when everything was wired, okay? Because you could define the traffic flows at the wire level. So now when we put the 5G network or any wireless technology in reality, we have a problem. We need to define the same enforcement boundaries and the same policies, but in a mobile network, okay? I'm not deep diving into how to do it, okay? But take the concept of this and how you implement this in a 5G or 4G private network. That's the point, okay? Part of the security measurements will be implemented inside or using the 5G network components, the ones that are in the standard or some functions that you will deploy in the network. Another part of the security needs to be implemented as perimeter security, like or zero trust access architectures that you put around the 5G network. Okay. What you need to avoid implementing precisely that is that let's say in a wireless scenario, you will have this PLC that we were talking about at the beginning of the presentation infected, and then some of the boundaries probably and hopefully will work and will cut the attack. But now, what you need to avoid is that the same PLC, that in this case is a wireless PLC, connects to the 5G network and then avoids all the different boundaries there, the minor, the major, everything, and reach another point in the network, which is a system operating the whole fabric and then shuts down the entire operation. So this is what you need to avoid. You need to implement those security measurements around the 5G network, okay? So with all the stuff that I was talking at the beginning, plus the 5G networks, now we need to think about the security as an end-to-end or as an holistic. Sorry for the word. I know it's a bit bullshit, but it's real in this case. You need to think about the security end-to-end. All along the cybersecurity lifecycle, let's take the NIST framework, and from all the different devices, all the different elements that are part of this life cycle, okay? So you need to think on everything, and if you forget some of these different domains, probably you will end creating a vulnerability, and then you will be attacked. Maybe not in day 0, but in day 1, and as everything and more time passes, you will create more vulnerabilities. So what we are doing at Telefónica is to think about the whole cake, and we are defining specific services and tools for every domain that you are seeing here. So we like to talk about resiliency. First, let's ask ChatGPT what resilience is, something that is resilient is. So the term resilient generally refers to the ability to withstand or recover quickly from difficult conditions. So what we are trying in Telefónica is not to avoid the risk. Risk is unavoidable. What we are trying is to transform our customers' companies into resilient or cyber-resilient companies. This is what we are trying to do. We assume that there will be breaches. We assume that there will be risk, but we are designing the architectures, tools, our SOC, so that we are resilient along with our customers. Okay, that's the point. So we have this equation: risk equals probability and multiplied by impact, and we are trying to reduce both. So we approach this in 4 different phases. The first one is know your posture. I will get into that in just 30 seconds. Defend the infrastructure, monitor and react, and manage your security end-to-end with a mission-critical SOC approach. Okay? This is the same as the previous slide, but put in a way that customers can understand, and that can understand as well our role. So know your posture. What this means? Basically, analyze what you have, analyze what you have configured in your different devices, tools, what you have connected to the network, which processes are in place, all this stuff. So what we ask are the right questions, okay? And we help ourselves with tools, like, for example, tools from Nozomi Networks, one of our partners. You can imagine, I let you make the photo, by the way. There's some people making photos. Take the picture. No, it's okay. So in the upper part of the slide, we see traffic analysis with the tools that actually make that. We create a real photo and an active photo of what the customer has in his network. So the result is something like that. This is from one of our partners. It's a random picture of the dashboard. Okay, we have our implementations. But you can see here how a specific tool that is deployed in the network actually gives you a lot of information about the different devices, mapped with the layers that I was presenting before, level 1, the devices, etc., and you can click and deep dive on any of those components and take and take a lot of information. Okay, so you can make decisions, implement the right policies, identify vulnerabilities. So the most important thing, there's a lot of stuff in this phase, know your posture, but the most important thing is you need to know what you have connected to your network every day and in every single moment. It's a real-time photo. Okay, that's the lesson number one. So we help you to build this picture. Defend your infrastructure. I covered this in the previous part. Here you have the example of the 5G network plus some stuff, but the lesson here, the main lesson here is segment your network, following the Purdue model, the EEC, segment your network. That's mandatory, absolutely. Protect the endpoints, so don't trust just network-based security. You need to protect the endpoints and implement traffic analysis tool, detection, basically OT-specific monitoring tools, so you can detect something and then react, as we will see later. Just one technical stuff. I don't want to be very technical in this keynote, but network segmentation, what means? You put a switch there. Here we have the same layers as we were seeing before. You have a switch, but you don't implement the policy at the switch level. You implement it at a firewall level. Why? Because it has more capabilities. You can put there in place more secure policies based on identity, and you can implement a real zero trust paradigm in this part of the network. If you just segment the traffic at a level 2 level, a VLAN level, then you can have problems afterwards, okay? Because it's not strong enough with the protocols and the activities that they have today. So this is what we mean by network segmentation or micro-segmentation in a network, okay? Just keep this. It's probably the top lesson here in the defend infrastructure. So we help our customers to micro-segment the network in the right way, along with other stuff in this phase. Detection and response. Here we have phases, what we usually follow to help the customer, but the main message underlying all the different phases is OT is different from the rest of the world, from IT. So you need to get the telemetry different, you need to build your dashboards different, you need to build your CM use cases differently, you need to put your threshold to detect and finally differently, and you need to react differently, because those are critical assets. If you, for example, have in IT, the typical reaction to a malware would be to shut down a machine and reboot it. In an OT environment, if you reboot the same Windows machine, you can shut down a production line. So you cannot react the same way as you are doing it in IT environments. That's really, really important. So let's take phase 1, 2, 3, 4, 5. The underlying concept is the same everywhere. OT is different, and you need to use specific tools for OT, and you need to use or implement specific processes for OT, okay? Here you have an example of what a Triton attack. This is the attack that occurred in Saudi, to a petrochemical Saudi company. That basically, it was a malware that infected some components, et cetera, et cetera. The thing is that they couldn't act as they would have wanted, because precisely this mission critical factor, okay? It is so special. Probably most of you know what Mitre attack matrix is. It's so special that they created a different matrix, Mitre matrix, with different techniques and stuff, because everything is specific for OT. Here you can see an example. You take the ICS. ICS is for critical systems. You can take this and you can find that the techniques and the detection and stuff, everything is specifically for OT. In controller is a malware specifically designed for OT. So if you are going to implement CM, for example, use cases, or whatever whatever the tool, you need to keep this in mind, okay? It is special, and you need someone that knows very well these kind of matrices and the processes, so they can implement the right use cases in the tools. And finally, people and tools, the SOC itself. We were talking about tools mainly. You need to build a SOC that has mission-critical purposes. Okay, you need to rethink the way you monitor stuff. You need to rethink the way the different operational groups work. You need to rethink the training you have. They have to be people with different skills than in IT. So in general, when you have a critical infrastructure, for example, as the one we have in our internal network, it's also a mission-critical infrastructure, the telecommunication network. We have a specific SOC monitoring this infrastructure, okay? And it's not just a general-purpose SOC. So tools, the threat intelligence, the ticketing, the processes implemented, everything is different. Because what you are seeing in the screens, to put just an example, and here we have a solution from Tenable OT Security, where you are seeing in the screens the events, the alerts, if you need to drill down on anything, is OT specific. So it doesn't make any sense that you put there to operate groups in the SOC that are not specifically trained for those tools and have the different processes. And by the way, just to finish the presentation, there's one specific thing in the detection and specifically in the response that is very different that this SOC needs to be very aware of, is that they cannot act alone as they in the IT environment that they do. They need to interact probably with the plant operators, with the technology operators in the plants to coordinate the response, which is not so agile as in the IT world, but it is what it is. Those are mission-critical assets. And with that, I would like to thank you for coming. That's all. If you have any doubt or you want to contact me for whatever, I'm here. And if not, I'm in Telefónica. You have my contact. So thank you very much.